Hi, we are from Group Hero. We are going to present about humidification and its application. This is our group member list. Humidification is the process of adding moisture to the air. It plays a critical role in many industries to ensure optimal conditions for various applications. Humidification involves introducing water vapor into the air to increase its humidity. Methods like evaporative coolers and steam humidifiers are used to increase humidity levels and maintain air quality. Water cooling towers help regulate temperature by evaporating water into the air. To reduce the heat in industrial systems and improve humidity control. These towers are used in large-scale industrial facilities such as power plants to lower temperatures and manage moisture levels.
Next, I will explain how does a cooling water works. A cooling tower works by removing heat from water through a simple process of evaporation. Here's how it works. First, hot water will enter the cooling tower. Then, inside the tower, the water is sprinkled over field packing. This is to increase the surface area for evaporation. Air then flows into the cooling tower and flows through the water as it falls. As the air and water come into contact, a small portion of the water evaporates. This evaporation helps remove heat from the water. The heat from the water is transferred to the air. The cool water collects at the bottom of the tower. Meanwhile, the warm air, now carrying the evaporated water, exits from the top of the tower. To sum up, cooling towers efficiently transfer heat from the water to the air through evaporation. This simple yet effective process makes cooling tower essential for many applications.
Next, I will explain about example 10.5-1, design of water cooling tower using film coefficient. From this question, we need to calculate the height of packed tower. All of these are the information and the diagram of water cooling tower, and below is the formula that we are going to use. First of all, we need to get H1 from the humidity chart. Given the temperature of the gas, 29.4 degrees Celsius, and we draw vertical line until 100% percentage humidity, and using the wet bulb temperature 23.9 degrees Celsius, and we draw the vertical line until 60% percentage humidity, and we connect both points and draw horizontal line to get 0.0165. Next, we need to get HY1 and HY2, and both of the formula is in the textbook. So for HY1, we got 7.17 times 10 cube joule per kilogram, and for HY2 we got 129.9 times 10 cube joule per kilogram direct air. We need to plot the equilibrium line using the value in table 10.5-1 and then draw the operating line with the point TL1 HY1 and TL2 HY2 that we already calculate. Next, we need to draw several lines from equilibrium line to the operating line using the slope negative 4.187 times 10 to the power of 4. For example, using HY2 129.9 times 10 cube and TL2 43.3 degrees Celsius, and we substitute the value into the formula of the slope. We got HY 184.3 times 10 cube. We need to obtain several values of HYI with the corresponding HY. And then we need to tabulate values of HYI, HY, HYI minus HY, and 1 over HYI minus HY.
From the graph, we have obtained the values of HYI and HY, and these values we will put in a table and get the values of HYI minus HY and also 1 over HYI minus HY. And from all the values we have calculated, we will then plot a graph which is 1 over HYI minus HY versus HY. And from this graph, we will get the area under the curve using the integration method. After the calculation, we will get the values that is 1.82. Next, we will now calculate the height of the tower Z using the equation G over MKP times with the integrated value we obtained. So from the question, we have obtained the values of kGa, G, MB, and also the pressure, which is kGa is 1.207 times 10 power of negative 7, and also the G is 1.356 kilogram per second meter squared, and also the molecular weight of air is 29 kilogram per kilomole, and the pressure is 1.013 times 10 power of 5. So from all these values, we will substitute them into the equation of Z, and we will then obtain the values that is 6.98 meter.
Moving on to the applications, humidification plays a vital role in food processing, pharmaceuticals, the textile industry, and also in HVAC systems. In food processing, humidification helps control drying processes to preserve the quality of products like meat, fruits, and vegetables. In the pharmaceutical industry, humidity control is used to ensure the product consistency. Inconsistent moisture can affect the stability of the medication and powders. In the textile industry, proper humidity needs to be maintained during fiber processes. It prevents static buildup and maintains the fabric's quality and texture. Whereas humidification in HVAC system helps to improve air quality, reduce dryness in air, and enhance comfort levels in residential and commercial spaces. In conclusion, humidification plays a vital role in food processing for freshness, ensures precise conditions in pharmaceuticals, enhances textile quality, and optimizes comfort and efficiency in HVAC systems.
Humidification is important in various industries to improve product quality and create a comfortable environment.